5 and 5. We know 5 and 4.
So the smallest prime number is 2. So you always start with 2 and you hope that it works. Does 2 go into 20?
Yeah.
Times 10. And then you try it again. If it works, you play sports. When you play sports, if something works, you try it again. Does 2 go into 10?
5 and 2.
2 and 5. Yeah. Now it's best to use the smaller number on the left in these factor trees and be consistent. You're done. A lot of students wonder, well, when are you done? You're done when it's all primes on the leaves, on the outer edge there. So let me give you a brief list of all the prime numbers here that you will likely need for today. You probably don't even need this high for like your class, but this is probably sufficient. Okay. Now, when you have this factor tree, do you remember what you're looking for? What allows you to bring something out?
Wait. I don't remember.
Okay. You're looking for pairs. So I always kind of think about like socks when I'm folding socks. I want to match up a sock with another sock. So when you have a pair, you can bring one out. But if you don't have a pair, you have to leave it in. Okay, so there's a part that goes outside the root and a part that goes inside the root. In this problem, a 2 goes out and a 5 stays in. And this is your final answer for this. Any questions on this?
No.
We're gonna do another one here before I have you try one. So let's do that. Let's look at the square root of 44. Okay. You always start with the smallest prime number, which is 2. Is 44 divisible by 2?
22.
Yes. And then if it works, try it again. Does 2 go into 22?
11.
11 times. 11 is a prime number. So you do want to have this kind of idea of which ones are prime numbers. So you're not sitting there guessing like, well, can I divide 11 by, 2 or 3 or something? You are done here. Any pairs? Do you see any pairs in this one?
2s.
So that means a 2 comes out and the 11 stays in. So the final answer is 2 square root of 11. Is it clear where the 2 comes from?
Yeah.
And why the 11 stays in? Great. So here's one for you to try. Square root of 12. Go ahead and try working that out and let me know what you come up with.
Okay, so there's a pair of like 2 and then 3.
Give me your final answer down here. What goes outside the root? What goes inside?
On the left is 2, on the inside is 3.
Okay, so this is stated as 2 square root 3. Okay, and then obviously you draw the symbol. Good. Okay, let's look at another example together here. Let's say it's the square root of 18. Does 2 go into 18?
Yeah. Wait. Yeah, 9. Yeah.
9. And if you're allowed to use a calculator, please have one out. Doesn't matter to me. I want us to do these calculations quickly. Does 2 go into 9?
No.
So the next prime number you try is 3. Does 3 go into 9?
Yes.
Goes in 3 times. So now notice you have a pair of 3s. So a 3 comes out, but that 2, go back to my sock analogy, it doesn't have anything to pair with, so it stays in. So this time your answer is 3 square root of 2. What do you think about that?
So it's just like the opposite if there's another pair.
If whatever the pair is, you bring that number out. If there's nothing to pair with it, it stays in.
Right.
Okay, so let's look at the square root of 63. Okay, does 2 go into 63?
No.
Does 3 go into 63?
Yeah.
Okay, how many times?
11, no, 21.
21, good. Does 3 go into 21?
Yeah, 7 times.
7 times. Now, why do we stop here? How do you know that you're done?
Because you can't divide. I mean, you can't divide 7 by 2 and get an even number
Or 3,
or a whole number.
because
Yeah.
7 is a prime number. These are all prime numbers on the leaves. You've got a pair of 3s, so this becomes 3 square root 7. Okay. All right, here's one for you to try. Go ahead and work that out and let me know what you come up with.
Hmm. Would it be 3 on the outside and 5 on the inside?
Did you write something like this?
Yeah.
Yes, that is correct. Good. Okay, so some other things to think about. Let's look at the square root of 8. Okay, square root of 8 is 2 and 4, and then 2 and 2. Do you see any pairs on the leaves?
Mm-hmm. All
Yes.
the 2s.
So just one pair. Okay, so this time it's 2 square root of 2. So it is possible for the numbers on the outside to be the same as the numbers on the inside. Sometimes that does happen. Let's look at the square root of 27. Square root of 27 is 3 and 9, and then 3 and 3. Do you see any pairs?
3.
Pair of 3s. And it doesn't matter if you see it as these being the pairs, that's fine. You know, you got a 3 that's coming out and a 3 that's staying in. All right. Okay, so new problem here, new problem for you to think about. Just a moment here, make sure the numbers work. All right, so let's look at the square root of 72. Does 2 go into 72?
No, wait, no.
It's an even
Oh, it
number.
does.
Yeah, if it's even, 2 will always work. What's the other number here? What is 72 divided by 2?
36.
36. And then does 2 work again?
Mm-hmm.
Okay. 2 and 18. Does 2 work again?
Yeah, 9.
Okay, but 2 no longer works.
3.
3 and 3. So notice this time there's a pair of 2s and a pair of 3s. So a 2 is coming out and a 3 is coming out. What's staying on the inside? If there's nothing to pair it with, it's going to stay on the inside. Okay, so we're going through this exercise because you've got to be able to do this on the test or quiz that's upcoming. And I want you to see here that it's possible for more than one thing to come out. Now, whatever comes out, you're going to multiply. And whatever stays in, you would also multiply if there's something else to go with it. So this becomes 6 square root of 2. Questions, thoughts on that? Any feedback for me? It's okay if you don't. I'm just asking if you need any clarification.
Like for my working class,
Yes.
it's like square roots, but there's like graphs. I don't know what she called it.
Okay. That's where it helped me to send over a picture of what you want to
Oh,
work
I
on.
could have sent a picture. Well, I'm on
Yeah.
the Zoom on a computer.
You can text, email a picture, drop it in the chat, whatever you want. You got to send over what you want to work on because I don't know. I'm going off of a guess here. And sometimes it takes a lesson or two to kind of get in the rhythm of it where you send it over ahead of time. So yeah, we still got 10 minutes here, 15 minutes. So why don't you send over what you want to work on? However you want to do that. You can text me, email me. You can have mom or dad text me.
You.
Let me drop my phone number for the business in the chat here. All right, so I've dropped it in the chat. You're welcome to send that over, and I'll be happy to look at what you got and create a lesson from there. This is a business phone, so you're welcome to text or call whenever. I'll only answer it if it's business related, but if you want to send over pictures ahead of time for the lesson, be happy to look at those problems.
So, inside of there. That might be a bad picture, but my back
Yeah.
camera's like weird, but it's sending.
All right, so I do see that you sent something over here. So my process is when I get the picture, I got to quickly upload it. You're right, the quality of this is not very good. It's almost unreadable. Is there any way you can send a better picture than this?
Yeah.
You're welcome to send a lot of pictures. It won't disrupt me if you send a bunch over.
Wait, I gotta take that.
All right, so got that. That's loading up now. Whenever you send over problems like this, I can either work through exactly what you have, or I can make up one like it, by just changing a number or two. Totally up to you. What would be best to help you?
Well, these are just like example problems, so you just make up some, I guess.
So is your test typically or quiz typically on like whatever he gives you, you'll get one like that on the test?
No, this is our like foldable.
Okay.
So our foldable, it just like shows us like the formulas. I don't know if we can use this one on the test.
Okay.
She didn't necessarily say, but like she did give us one before that we were allowed to use in the test, and this just shows us like formulas usually.
Got it. Got it. Okay. So here I've got a function up in front of you. Hopefully you can see that square root of x minus 2. I'm going to put a table now down for us to work through. X and f of x, 0, 1, 4, and 9. Okay. So what this table is suggesting to you, it's suggesting you to take these x values and put them in for x. Okay. So for this first one, it's like saying the square root of 0 minus 2. Okay. Can you tell me what the square root of 0 is?
1.
Square root of 1. 0. Square root of 1 is 1. Square root of 0 is 0. So this is 0 minus 2. What does that become?
-2.
-2. Good. And then the next one I've got up there, square root of 1 minus 2. What does that become?
-1.
So 1 minus 2, -1. You're good. How about square root of 4 minus 2?
It's 0.
It is 0. How about the last one, the square root of 9 minus 2?
1.
1. Good. Okay. Next thing is to make a graph. Okay. Rough sketch. Okay. And for me, like this does not need to be any artistic thing here. Basically, it's just like, do you know where to put the points? There's 0, -2. Here's 1, -1. 2, 3, 4. There's 4, 0. And then if we keep going out, 5, 6, 7, 8, 9, there's 9, 1. So the thing with the square root, it always has this kind of a shape where it goes to the right, up and to the right. So your graph needs to have that sort of shape. You don't have to be very artistic. You don't have to be the best at drawing. You just gotta have to have something that looks reasonable. Make it look so that your teacher isn't questioning whether you understand this or not. Any questions on that?
No.
Okay, so the next thing it asks you for is what's called the domain and the range.
Yeah.
You've got some good stuff on your notes there. The domain is, you can think of domain as the X values, but you may more generally want to remember it as left to right. Okay, so when you look at this graph here, what is the leftmost X value?
0. We know.
Yes,
Yeah.
yep, 0. And what's the rightmost X value? How far to the right does this
9
graph go?
or infinite?
Infinite, right? So there's a couple of ways to do this. I guess you're using
All real numbers, like symbol, maybe.
yeah. So even though what you just said is correct, it looks like your teacher wants you to do this X greater than or equal to 0, which means all the numbers to the right of 0. All right, the range, I know that maybe that wasn't clear, but let's just do a few more parts of this. So range is the Y values. It's typically min to max, okay? Or you can think of it as like bottom to top.
He does up, down, or
Up,
down, up.
down to up, yeah. Any of those are good. You can decide what words you like. So the smallest Y value is right here, okay? So that's -2, and then notice it goes up forever. Okay, so y is greater than or equal to -2. Questions on that?
No.
All right, so now the next thing that it asks for is what's called the x-intercept and the y-intercept. We'll do them one at a time. The x-intercept is where it crosses the x-axis. Okay, so if you go look at the graph visually, where does it cross the x-axis? What is the x value there? Is what I'm asking you clear or not? Maybe you're muted. Nope. Blaize, can you still hear me?
Yeah.
Okay, just asking you where the x-intercept is. What's the x
sorry.
value?
0, 4.
So 0, 4 would be up here.
Oh, 4, 0.
4, 0, good.
Yeah.
Okay, so your instructor is looking for something like that. They're looking for the ordered pair 4, 0, or maybe even x equals 4. The y-intercept is where it crosses the y-axis. Not much mystery there, or touches, could touch. But x-intercept, x-axis, y-intercept, y-axis. So if you go back to your graph, where does it touch or cross the y-axis?
-2. Oh, 0, -2.
0, -2, or you might write y equals -2. Now, just for your sort of like, to help you guide you through doing some of these problems, they generally, well, actually, I can't say that. They don't always have an x-intercept. They don't always have a y-intercept, but a lot of the times they do. So it's like the 80-20 rule. It'll work for a lot, but maybe not. All right, so let's look at another problem here. You said you're pretty solid on average rate of change?
Yeah.
Okay, so let me just give you a quick one to think about. Let's say f of x equals 2 square root of x, and I want the average rate of change from x equals 1 to x equals 9. Okay, so you typically get a formula for average rate of change, something like this: f of b minus f of a over b minus a. Does that look familiar to you?
Wait. No.
Okay. So maybe you're used to the y2 minus y1
Yeah, y2
x2.
minus my 1
Okay.
x2
All right.
minus. Yeah.
All right. So while what I showed you is correct, let's not use that. Let's focus on this one here. This is x1, this is x2. How do you get y's from x's?
You substitute in the x.
Right. So you have to find f of 1, 2 square root of 1, and then f of 9, 2 square root of 9. Could you calculate both of those for us, please?
Wait. Is the first one 4? No.
It's 2 times the square root of 1. The square root of 1 is 1.
Oh, wait. Oh, so it's just 2?
Just 2. How about for the second one? Start with the square root of 9.
6.
The final answer is 6. Good. Okay, so now you have your values. Your y2 is 6. Your y1 is 2. Your x2 is 9. Your x1 is 1. So we're just putting those values back into that equation there.
Oh, 6. 4 over 8.
Okay, and what does that equal?
2.
Try again. That's 8 divided by 4. What you just said. 2 is,
Oh,
gave,
0.5?
yes, or 1/2. All right, very good. So we're kind of right at the middle point here for the lessons. They're 50 minutes. So if you want to ask your brother to jump on, happy to help. For Thursday though, please try to have something sent over ahead of time so we can get going on it right away. Good job today. I'll see you.
I'll go get 'em.